Hello friends. Welcome back to the channel. Today, we are going to learn something very important for every instrumentation engineer, the wiring configurations of transmitters. Specifically, we'll cover 2-wire, 3-wire, and 4-wire transmitters. This is a common topic in industrial automation, and understanding it deeply will help you in troubleshooting, installation, and design work. So, let's dive in. A transmitter is a field device that measures a process variable like pressure, temperature, level, or flow and sends that signal to a control system, usually as a 4 to 20 mA current signal. But how do we power these transmitters and send the signal? That's where wiring configurations come in. Let's start with the 2-wire transmitter. This is the most common type in process industries. In this configuration, the transmitter uses the same 2 wires for both power supply and signal transmission. Here's how it works. The power supply, usually DC 24 volt, is connected in series with the transmitter and the control system input. The transmitter draws power from the loop and sends the 4 to 20 mA signal back through the same wires. This is called a loop-powered transmitter. Advantages? It's simple, cost-effective, and requires less wiring. But remember, the power supply must be sized correctly because the transmitter and the control system share the same loop. Next, the 3-wire transmitter. This design separates the power supply and the signal return. One wire is for positive power supply, plus. Second wire is for negative power supply. Third wire is for the signal output. This means the transmitter gets a dedicated power supply, and the signal wire goes to the PLC or DCS input. Why use 3-wire? It reduces voltage drop issues and provides better stability for the signal. However, it needs an extra wire compared to 2-wire, so installation cost is slightly higher. Finally, the 4-wire transmitter. This is usually used for smart transmitters or devices that need more power, like those with displays or advanced electronics. 2 wires are for the power supply, AC or DC. 2 separate wires are for the signal output. This completely isolates the power circuit from the signal circuit, which improves accuracy and eliminates interference. The downside? More wiring and higher cost. But for high-performance applications, it's worth it. Let's summarize. 2-wire, loop-powered, simple, widely used for pressure, temperature transmitters. 3-wire, separate signal return, better stability, used in some level or flow transmitters. 4-wire, full isolation, used for smart or high-power transmitters. Always check the transmitter datasheet before wiring because wrong connections can damage the device. So friends, that's the detailed explanation of 2-wire, 3-wire, and 4-wire transmitter wiring. If you found this video helpful, please like, share, and subscribe for more instrumentation and automation tutorials. And don't forget to comment below, which type of transmitter do you use most in your plant? See you in the next video.